Everyone, my name is Thuye, representative of Vietnamese team in Group 3. Today we would like to talk about hydrogen energy. But before we get into the specifics, I would like to talk about what makes hydrogen so appealing as a renewable resource. Now, hydrogen is considered an excellent clean energy carrier because it solves some of the biggest challenges of the transition away from fossil fuels. Well, hydrogen itself is not a renewable energy source, but it must be produced from other energy sources. It becomes a renewable fuel and it's made using renewable electricity. There are three things that make hydrogen very appealing. The first one is it has zero carbon emissions when used. Now, when hydrogen is used in a fuel cell or burned with oxygen, the primary byproduct is water vapor, not carbon dioxide. So you can see in this fuel cell reaction here, it only produces water and a bit of electricity and heat. This makes hydrogen an excellent option for reducing greenhouse gases in transportation, industry, and mostly power generation. Now, it also can store renewable energy. Renewable energy sources like solar and wind are intermittent, which means that they rely on weather. It only creates electricity when the sun shines or the wind blows. On the other hand, hydrogen can store excess renewable electricity during periods of high generation in long term. It's an excellent choice for long-term storage. Lastly, it contains a lot of energy by mass. As you can see here, hydrogen has a staggering 120 megajoules per kilogram, a very high energy density, compared to the more common fuel sources like gasoline, diesel, and coal. And this high energy density, by the way, makes hydrogen very attractive for aviation, shipping, spacecraft, and heavy-duty trucks. Now, let's move on to what the Japanese team have to say about hydrogen.
First, I'd like to talk about what is hydrogen energy. Overview. What is hydrogen? It's the lightest element, the most common element in the universe. It is found in water and many other materials. Next, characteristics of hydrogen as an energy source. It doesn't produce carbon dioxide when it is used. It can make electricity through fuel cells. To put it simply, hydrogen in oxygen in electrons flow through the circuit and electricity produced. And next, it is made from various resources: fossil fuels, biomass, renewable energy, and others. Next, pros and cons. First advantage. It doesn't produce carbon dioxide when it is used. It helps reduce global warming. It can be used in many areas, such as transportation and factories. It is also used in rockets. In the future, it is also expected to become a means of storing large amounts of electricity over a long period of time. Disadvantages and disadvantages. Producing green hydrogen is expensive. It's difficult to store and transport hydrogen safely. There is a risk of a gas leak. It might explode. there are not enough hydrogen stations and other facilities. Today, most hydrogen, gray hydrogen and blue hydrogen, is made from fossil fuels, so it is not always environmental. It will take time for green hydrogen production facilities to become widespread.
I will tell you about global trends in hydrogen energy. Current hydrogen technology is developing all over the world, but it is expensive because production and transportation costs are high. Many companies find it difficult to make a profit, so government economic support is important. Most important future is hydrogen improved production storage, utilization, transportation. These short five states of hydrogen development. Next, the major hydrogen producing countries are China produce about 133 million tons per year, and United States, Saudi Arabia, Russia, and Middle East countries. Vietnam will develop in cooperating with Germany and Japan. This photo here is the port of Thuye, an important thing in Japanese hydrogen in this history.
Next, we would like to talk about hydrogen development in Japan. First, I explain Japan's basic hydrogen strategies. Japan sets some goals. First goal is carbon neutral by 2050. It is a fundamental goal. Second goal is to construct hydrogen supply chain. Japan tries to make a flow, production, trade, transportation, and utilization. Third goal is to diversify procurement places of resources. So Japan has to expand overseas markets.
Next, I will tell you about the current hydrogen project. Projects related to the production, transportation, and use of green hydrogen at home and abroad. For example, the world's first demonstration experiment to liquefy and transport hydrogen produced in Australia by sea is underway. Also, companies and local governments work together to develop supply infrastructure in coastal areas and develop projects to promote using environmental fuels such as fuel cell ships and marine ferries. In addition, fuel cell bus and taxi using hydrogen are actually operating in Kobe. Because it generates electricity with hydrogen and runs the motor. It emits almost no CO2 while driving, only water is empty. In Japan, technology that not only produce but also uses hydrogen is being promoted. Next, I will tell you about hydrogen production, transportation, and utilization. Hydrogen is produced to minus 235 degrees Celsius to 90 degrees and the is about 1/800 of the gas and transported at dedicated ship or truck. because it does not contain carbon. It does not produce CO2 when burned, and electricity can be extracted by reacting it with oxygen.
Next, I talk about the government policy. Japan has two policies of hydrogen. One is hydrogen basic strategy. It is planned in 2017 and revised in 2023. It is planned for carbon neutral by 2050. Another is hydrogen society promotion. It is planned in 2024 and it promotes state of low carbon hydrogen. And then let me explain future plan. Japan try to introduce 3 million tons of hydrogen by 2030. 20 million tons of hydrogen by 2050. Japanese government invest 150 trillion yen back to construct hydrogen supply chain and reduce the supply cost. Japan faces the problem that hydrogen cost is too expensive. So, therefore, Japan tries to reduce the cost from 100 yen to 30 yen normal cubic meter by 2030. 20 yen normal cubic meter. 20 yen normal cubic meter by 2050.
I talk why is Japan promoting hydrogen energy. In Japan, the share of renewable energy is about 23%. However, there are few locations available for building power plants and power generation is unstable, so renewable energy can provide all of the electricity needed in Japan. Japan has set the goal of achieving carbon neutrality by 2050. However, it's difficult to do this within Japan alone. So far, generating renewable energy in conflict with favoring geographical functions and transport hydrogen to Japan, we can achieve carbon neutrality. Concept that is company development Swiss Columbia that is ship carrying hydrogen in 2022. This could hold hydrogen to 4 Kelvin, reducing its volume to 1/800 of its original size. This is the world first. That's why it gives us an advantage in terms of industry.
Okay, that was the Japanese team's work about hydrogen energy. Now we would like to move on our Vietnamese team's efforts on research.
Moving to hydrogen development in Vietnam. Vietnam approved its first national hydrogen energy development strategy to decision number 165 in February 7, 2022, establishing a roadmap to 2030 with a vision to 2050. The strategy aims to develop a stable hydrogen value chain supply, which includes production, storage, transportation, distribution, and end use primarily based on renewable energy to support the country's energy transition and net zero emissions target in 2050. When fully developed, hydrogen energy is expected to improve national energy security and stability. This energy source also reduce greenhouse gas emissions and also support Vietnamese green strategy. Furthermore, hydrogen energy also develop a domestic hydrogen industry capable of exporting green hydrogen and hydrogen derived fuel. Regarding key objective, hydrogen production is expected to reach about 100,000 to 500,000 tons per year in 2030 and 10 to 20 billion tons per year in 2050. Vietnam also focused primarily on green hydrogen and low carbon hydrogen in 2030 and want to achieve concentrate in large-scale domestic use and export in 2050. Now we move into current hydrogen project. Despite being in its early stages, several promising and commercial-scale hydrogen energy projects have been announced. For example, PBS green hydrogen pilot, which is located in Zinco gas processing plant in Bà Rịa Vũng Tàu, developed by Petrovietnam or PBS. This project uses solar power as renewable source, and the expected hydrogen output is estimated around 30 to 40 tons per year. This project serves as Vietnam's first practical demonstration of renewable power hydrogen production and serves as a pioneer for future projects. Regarding proposed IDF project about renewable energy, industrial hub, Petrovietnam is also making renewable energy service, industrial sector in Vũng Tàu that will support offshore wind development, green energy production, export, infrastructure and manufacturing of wind foundation and substations. Speaking of proposed large-scale green hydrogen projects, several domestic and international developers have announced feasibility studies for offshore wind power hydrogen production, among the production for export, and also focus on hydrogen supply for industrial users. Many of these projects remain in the planning or investment preparation stage. Will regulatory frameworks continue to develop?
To support the growth of Vietnam's hydrogen economy, the government approved the National Hydrogen Strategy, and in 2024, the BCT introduced an implementation plan to coordinate its development. The policy focuses on three main areas: building a complete hydrogen ecosystem through production, storage, transportation, and distribution; research and technical standard collaboration programs; attracting investment through public-private partnerships, foreign investment, and climate finance. Finally, promote hydrogen use in electricity generation, heavy industry, fertilizer production, and so on. These policies are aligned with Vietnam's Power Development Plan for Aid, National Energy Master Plan, Green Growth Strategy, and the country's net zero target by 2050.
Moving on to future directions. Looking ahead, Vietnam aims to become one of Southeast Asia's leading producers of green hydrogen by taking advantage of its abundant renewable energy resources, especially offshore wind and solar power. By 2030, the government plans to produce up to 500,000 tons of hydrogen per year. It also aims to expand pilot projects into commercial production, build infrastructure for hydrogen storage and transport, introduce hydrogen in power plants and heavy industries, and develop technical standards and certification systems. Looking further ahead to 2050, Vietnam targets an annual production of 10 to 20 million tons of hydrogen. Hydrogen is expected to contribute around 10% of the country's electricity generation, with widespread use in industry, transport, and energy storage. Vietnam also plans to expand exports of green hydrogen along with green ammonia, integrate hydrogen with offshore wind, solar, and carbon capture technologies, and finally establish itself as a regional hub for hydrogen production and export.
Okay, now I would like to talk about what hydrogen technologies that the world has developed. Now, hydrogen is a relatively simple gas, but there's a lot of ways to attain hydrogen. There are three main types of hydrogen gas used today: green, blue, and gray hydrogen. I would like to talk about gray hydrogen first, the most economically available. Green hydrogen is obtained as a byproduct in natural gas, which we also gain petroleum and diesel from. This hydrogen therefore contains a lot of carbon impurities and particles, and as a result, it has a very high carbon emission rate when used. But on the other hand, it is very commercially available, so it's cheap and readily used in these petroleum technologies. Next up is the blue hydrogen, which is also obtained from natural gas. But before being used, it goes through another layer of filtering. So the particles and carbon pollutants are taken out of the gases. This greatly reduces the emissions from hydrogen usage, but it is not perfect. It still contains minimal amounts of carbon and also requires a bit of technology and expertise to operate the gas. Last one being the green hydrogen. This hydrogen is completely generated through the electrolysis of water. So you split water into oxygen and hydrogen. This hydrogen is obtained through renewable sources like solar panels and wind energy to perform the electrolysis reaction. But there's a downside, a big one of that, which is it is very expensive and energy consuming. But it is clean. It has nearly zero carbon emissions, and well, it's pretty good for general usage. And you can see there's a dynamic here. The higher the cost, the lower the carbon emissions, and vice versa. Okay, so there's also a few methods of storage and transportation of hydrogen. As you can see here, there's a liquefied hydrogen tank in the NASA Kennedy Space Center. Hydrogen is a relatively simple gas, but it is difficult to store and transport because it has a very low density under normal conditions. Although hydrogen contains such a high amount of energy per kilogram, it occupies much more volume and much more volume than your average daily use. Therefore, special contained methods should be used to move around this gas. So there are four main ways that people have developed. The first being the most simple. The simplest one is basically you compress compress it into cylinders, as in big hydrogen tanks that contain high pressure hydrogen. This is the most simple method and most readily available. But there's one downside, which is you can't store really much hydrogen in this type of container, and it is quite heavy when it stacks up. The next one being liquid hydrogen. Now, instead of storing hydrogen as a gas, you liquefy it under negative 250 degrees Celsius until it liquefies. This method allows for large quantities of high energy liquid hydrogen to be transported. The main downside is keeping that cold temperatures. Negative 250 degrees Celsius is a critically low temperature to maintain for a long period of time. So it does require a lot of energy to store hydrogen, which could be sometimes counterintuitive, as you're using energy to store energy. The third method being metal hydrides, or as we call it, the solid state storage. Certain metals and alloys absorb hydrogen into crystal structure, as if you soak up water with a sponge. And there are a few alloys, which are magnesium hydride and nickel hydride, and a few titanium and other alloys. And it is by far the safest method of storing hydrogen. But those metals and alloys that I mentioned are quite expensive and sought after. So this is not the most economically ready type of storage. The last one being the chemical hydrogen carriers. Hydrogen is stored under chemical bonds in a few molecules such as ammonia and methanol, and some other few organic particles. These type of compounds are reducers, which mean they readily give up hydrogen when needed. But there's a downside. These chemicals are highly toxic in high concentrations, so moving them around without precautions is a large hazard if you're not prepared. But it is also the most economically friendly one when moving with big ships and moving internationally, because you can store a lot of ammonia and methanol in liquid form compared to liquid hydrogen. Next up, the safety issues. Hydrogen is a very reactive gas. It readily combusts at room temperature with a simple spark. But, well, it is a clean energy carrier, but we still should take care of it. As you can see here, this is the 1932 Hindenburg airship disaster. This terrible disaster is caused by a few mishaps in electricity, the airship. And as the airship is filled with entirely hydrogen, it combusts immediately, and this is not a good look for hydrogen. And we should take care of it. But how? And there are a few ways to safely operate hydrogen. The core principle when dealing with most gases is having an airtight seal, which means that containers do not leak any type of gas whatsoever. And if you should monitor the leakage of gas. You should always measure the concentration of gas in the air. When large amounts of hydrogen is leaked out, you must immediately evacuate the area, because hydrogen is very unpredictable. It will explode spontaneously, and there's not really much time to react when that happens. But what if that actually happens? You really should try to put down the fire, because hydrogen fire is different from gasoline fuel or other types of fire sources, is that it's a gas. You can't put it down in any conventional way. So you should probably follow the fire department, and if you can, shut off the hydrogen supply and evacuate everyone from the den. And that's my talk.
For the next part, we will compare between Vietnam and Japan in the hydrogen technology. So for the comparison, For the first category, is the main focus of hydrogen energy policy. For Vietnam, Vietnam tries to build a policy and investment framework and also try to innovate demonstration projects and attract foreign investment. And for Japan, has a large-scale deployment and usage of hydrogen, and they also import hydrogen and try to decarbonization of the industrial, many of the industries. And for the technological development, for Vietnam, current activities include a small scale of electrolysis, limited renewable power hydrogen production, chiefly used in fuel cell vehicles. And for Japan, hydrogen is widely commercialized and adapted for transporting like car, buses, trains, and ships. And in Vietnam, the current hydrogen projects include the traveling hydrogen plant and Petro-Vietnam initiatives. And for in Japan, the Fukushima hydrogen energy research field. And for what both countries could learn from each other. What Vietnam can learn from Japan. Japan already has like a long a useful model for developing a complete hydrogen economy, and therefore Vietnam can develop a long-term national planning. And Japan's success from hydrogen economy comes from the consistent government support over many years, and therefore Vietnam would maintain a long-term investment incentives, develop a stable hydrogen regulation, establish clear technical standards. And Japan actively promotes hydrogen use in transportation, power generation, and energy for residential use and heavy industry. Vietnam could stimulate the demand by supporting hydrogen adoption in sectors where electrification is much more harder, like in steelmaking, fertilizer production, shipping, and in long-haul transport. And for what Japan could learn from Vietnam, although Japan is much more advanced technologically, but Vietnam can offer several advantages. We all know that Vietnam has abundant resources like in solar energy, offshore wind, and hydropower. These resources enable low-cost green hydrogen production, whereas Japan has more limited domestic renewable resources and depends a lot on imports. Therefore, and Vietnam also offers a lower labor cost, lower land cost, and a strong potential for large renewable energy projects. These factors could make Vietnam a competitive exporter of green hydrogen and green ammonia.
Okay, so that was the overall technology surrounding hydrogen. So what do we think about hydrogen? We can see it as a simple gas. It's all over the world. It's in the atmosphere, it's in water, it's in our bodies, but it is tricky to handle. It is quite a simple gas in terms of usage. So you basically just burn hydrogen to get water, and vice versa. You split water to get hydrogen. But handling this gas is tricky because it has a lot of unusual properties. One of them being very low density, so it easily floats and spreads everywhere, which causes danger. But with enough cooperation between countries, we believe that in the near future, hydrogen can be tamed and stored and utilized around the world because it is such an excellent energy source without carbon emissions. And thank you for listening. That is the Group 3's Hydrogen Energy presentation.
Thank you very much to the third group for a wonderful presentation. Those presentations were truly interesting, weren't they? Next, we would like to invite our teachers to share their comments and feedback on the group presentation. Let's give our teachers a warm welcome.